guys, welcome to module 2 of basic engineering mechanics. We'll see the learning outcomes of today's class. So we'll try to express a two-dimensional force in terms of rectangular components. Then we'll try to express the force in parallel and perpendicular components, and we'll apply the vector addition to find the resultant of more than one. So in rectangular components, suppose we have a system, coordinate system, which is x and y. Okay, now this is the force F. Now the value of force is suppose 100 newtons. Okay, so this is Fx and this thing is Fy, and now the suppose slope is 3 by 4. It's on the slope of 4 over 3. So Fx will be, as we know, if you apply right angle formula here, so Fx will be f times cosine of the slope. Okay, so cosine of the slope will be 3 by 5 times 100, that will be 60 newtons. Okay, so this will be the value of Fx. Now if we try to find out the value of Fy using the same way, so we can write Fy as f times sine theta. So that can be written as 100 times, and we apply sine theta is height upon hypotenuse, that will be 4 by 5, that will be of 80 newtons. Okay, so this is the way you can express the force in rectangular components. So if I have to write the net force, the force will be 60I plus 80 J newtons. So 60 newtons in I direction, 80 newtons in J direction. Okay, now if we have to represent the forces in parallel and perpendicular components, so how we can do that? Suppose there is a surface. Okay, that surface is over the slope of 3 by 4, and there is a load W, and this will be the perpendicular component over the surface. I will be representing that thing W perpendicular, and this will be the parallel component. So how we can write, and if you apply the geometry here over here, you can easily find out this is 4 over 3. Okay, so how we can write that? So W perpendicular can be written as perpendicular in the side of perpendicular, that will be 4 by 5 times of W, and W parallel can be written as 3 by 5 times of W. So while I'm explaining you this thing, I am thinking that you all know the basic laws of the right angle triangle. So if you have any confusion in that, please clarify those confusions over a Google or somewhere, or a notebook or textbook, and then you'll be understanding this thing, because this slope thing you have to properly mention what slope is where. So if you are confused in this thing, you should first of all clear that thing, and then you come back here. Okay, so this is the way we can represent 2D force in parallel and perpendicular components. Okay, now we'll go for an example. So suppose if we have more than one forces, and the forces F1 is 40I, 40 in the I direction, plus 30 in the J direction, and F2 is minus 60I and 50 in the J direction, then what will be the resultant? The resultant we can write as summation F is equal to 40 minus 60 in I direction plus 30 plus 50 in the J direction, and that can be written as minus 20I plus 80 J newtons. Okay, so this is the way we can use the parallelogram law for vector addition. Okay.